Okay, part 3 of 17.2 deals with the region between the curve and the y-axis. Okay, y-axis. So far what we have done is we have nailed between the region between the curve and the x-axis. So when it's the x-axis, we integrate with respect to x. Now, in similar fashion, if you want to find the area bounded between a curve and the y-axis, what you need to do is to integrate with respect to y itself. Okay, and the limits, right, are C and D. Okay, never mind, I will show you what I mean. So just remember, area between a curve and the x-axis, you integrate with respect to x. However, you need to change it around. If you want to find the area bounded by a curve and the y-axis, you need to integrate with respect to y. Okay, now, it is given that y equals to 9x squared. Okay, find the area of the shaded region bounded by the curve. Okay, and the y-axis and the line y equals to 1 and y equals to 9. So now y-axis. So before we can even integrate with respect to y, we need to do some manipulation. So first, y equals to 9x squared. Then, we need to make the equation so that x becomes the subject of the formula so that we can integrate with respect to y itself. So what I will do here is this. If I simplify, okay, I will jig, okay, the equation up a bit. So what I get is x squared is 1 over 9. Y over 9. So x, right, is square root of both sides. It will give you 1/3 and y to the power of half. Now, okay, if I want to find that area, what I'll do is area equals to the integral of 1/3 y to the power of half. So I just factorize out the 1/3 is a constant. So y to the power of half with respect to y. Okay, let me just highlight this again. Okay, and the limits are 1 to 9. So the integration is the exact same thing. Okay, so y to the power of half plus 1 is 3 over 2. Then 1 over 3 over 2 gives you 2/3. Hence you get 2/3 y to the power of 3 over 2. And the limits are 9 and 1. So what I get is okay, you can factorize the 2/3, so you get 2 over 9. Okay, so y to the power of 3 over 2, so it's 9 to the power of 3 over 2 minus 1 to the power of 3 over 2. So what you get is 5 and 7 over 9 units squared. Okay, so the main learning point here is we're integrating with respect to y. Okay, please attempt try 10. I won't speak so much about this. I think it's quite doable. And we're ready, unpause the video. And we have try 10. Okay, first and foremost, what you need for try 10 is to actually make x a subject of the formula. Okay, so x is 2y to the power of negative half. Then you are integrating with respect to y, and the limits are 1 to 4. So if you just do all of that, what you should get is 4 units squared. Okay, example 11. So example 11 shows this. Okay, example 11 looks like an easy question, but it's not that simple. So if you notice, what happens here is this. What we want is to find this. So theoretically, we can just integrate ln x with respect to x, okay? And then we use the limits of 3 to 1. Then we pause for a while. Okay, I don't think I've learned how to integrate ln x. So there's no rule that I've learned how to integrate ln x till this moment in time. So how now? Okay, what we can do is this. Instead of finding p directly, what I can do is I can actually attempt, okay, to draw a line here. I find this area that's called q. Then once I find q, I find the area of the rectangle itself. I minus away area q. What I'm left with is the area of p. Okay, so all of this trouble stems from the point that you are unable to integrate ln x with respect to x. Can? Okay, so if we are unable to do that, what I can do here is this. First and foremost, now that I need to find Q, means that I need to integrate with respect to y itself. That's number one. Number two, I also need, right, the y coordinate here so that I know what are my limits. So first and foremost, when x equals to 0, okay, when x equals to 3, so when x equals to 3, my y value is equals to ln of 3. Hence, okay, if I just zoom in, this point here is ln of 3 itself. Then what I can do here is this. I need to make x the subject of my formula. So if y is equals to ln of x is equals to e to the power of y. Then if I integrate e to the power of y with respect to y from ln 3 to 0, so what I get is e to the power of y. You differentiate, integrating e to the power of y, you differentiate y is 1, so you get back the same thing. So what I get here is the limits is ln 3 to 0. So e to the power of ln 3 gives you 3, e to the power of 0 gives you 1. So here is you get 3 minus 1 is equals to 2 unit square. Okay, so this is not the end. That's only the area of Q. So let me just label that. So now, what I need to do is to find the area of rectangle. So the area of my rectangle itself is equals to length and breadth is 3 times ln 3. So to find area of P, what I get is 3 times ln 3 minus the 2 units. So if you use calculator, what I get is 1.30 units square. Okay, please pause the video, try 11. Same thing, this is a very special case because you are unable to integrate ln x with respect to x. So you need to go and express it in terms of make x a subject, integrate with respect to y to find the area of P. So, same thing, okay, what we get here is this. First, if you express y equals to ln x, you express it in index form, e to the power of y is equals to x. So what I'm doing here is I'm integrating e to the power of y, and my limits is ln 2. How did I get ln 2? Over here, my x value is 2 to get my y value. So I just sub in x equals to 2. Over here, my y value is ln 2. Hence, I'm integrating from ln 2 to 0. Then what you get is integrating e to the power of y with respect to y gives you back e to the power of y. Then what we have is ln 2 and 0. So if you work out everything, you find the area of region Q is 1 unit. Now where is region Q? Let me just draw it out for you here. Okay, this is Q. Then, okay, what you get is you take the area of the rectangle. So the area of the rectangle is 2 times ln 2. The length is 2. The breadth is ln 2. Okay, minus 1, area of Q. It yields the area of region P, which is 0.386 units square.